Given two numbers m and n, then show that the product of the numbers m and n is equal to the product of their LCM lowest common multiple and their HCF highest common factor. So let's, for example, do it for the two numbers. Now let m be 12 and then n be 8. Now we are going to show this for the numbers m equals 12 and then n equals 8. So m equals 12 and then n equals 8. So first of all, we are going to find the LCM lowest common multiple of the two numbers and the HCF of the two numbers 12 and 8. So let's find them in this way. We have two numbers 12 and then 8. So you see we are going to use the factors. Now if we put 2 and we take 12 divided by 2 equals 6, and then 8 divided by 2 equals 4. Then 6 and 4 have the same factor, the common factor we can put also 2, and then 6 divided by 2 equals 3, and then 4 divided by 2 equals 2. Then here we can also put 2, and then 3 divided by 2, because 3 is an odd number, it's not divisible by 2, we have to copy it again here, 3, and then 2 divided by 2 equals 1. Then here we remain with 3 and 1. We cannot put again 2. Let's shift and put 3, and then 3 divided by 3 equals 1. Then 1 divided by 3 is not possible. We need also to copy 1 here. So we'll have 1. Then we'll remain with 1 and 1, and we end our table here. So now let's have the LCM, lowest common multiple, which is equal to now the product of all factors we've found here. So we'll take 2 times this 2 times this 1, this 2, then times this 3. We'll have 2 times 2, which is equal to 4, then 4 times 2 is equal to 8, then times 3 will give 24. Then the same HCF, highest common factor, when we find the highest common factor HCF by using this method from these factors, now we select the factors which were common to both numbers we were given. So here, if we take these two, we have seen that it has divided this 12, and we've got 6, and it has divided this 8, and we've got this 4. So we'll write 2, and then for these 2, we've seen that it has divided this 6, and we've got 3, and again it has divided this 4, and we've got these 2. So 2 was common, write 2. Then for these 2, we've seen that it has not divided these 3 because we have copied these 3 here, but these 2 has divided this one, and we've got this 1, so means these 2 was not common to these 3 and these 2. The same case for 3. Here 3 has divided this 3 and we've got 1, but it has not divided this 1 because we have copied this 1 here. So means this 3 was not common. Implies that these 2 and this 1, these 2 and these 2 were the only factors which were common to 12 and 8. So we need to find their product now. So 2 times 2 gives 4, which is the required HCF, highest common factor. Now our task was to show that M times N equals LCM of M and N, then times HCF of M and N. So M and N, M times N now will be equal to the given numbers 12 and 8. So we'll have 12 times 8, which must be equal to the LCM, which is 24, then times the HCF, which is 4. So if we take 12 times 8, now 8 times 2 is equal to 16. I write 6 and I keep 1 here. Then 8 times 1 is equal to 80, then plus 1 is equal to 96. So here 24 times 4. If we take 4 times 4 is equal to 16. In the same case, I write 6 and I keep 1 here. Then 4 times 2 equals 8, and then 8 plus 1 equals 9. What do we find now? We find that the product of M and N, which were given, is now 96. And then here, the product of the LCM of M and N and HCF of M and N now, again, is 96. For the numbers M and N, which were 12 and 8. So this one is proved.